guys, welcome to my YouTube channel Maths World. So in this video we are going to see about introduction to real numbers. So basically what we are seeing is what we will just recall what we have studied in class 9, which we are going to use here in our actual chapter real numbers. Okay, let's get started. So basically our number system consists of different types of numbers, right? So basically it is divided into real numbers and imaginary numbers. Have you ever heard of this word imaginary numbers? Yes or no? No? It's okay. No need to worry about this now. We'll study about them in your later classes. Basically imaginary numbers contain an I in them, which you will study later. Now we'll see only about our real numbers, okay? Our real numbers are again divided into rational and irrational numbers. In your rational numbers only you have all your natural numbers, whole numbers and integers, right? Let's see how. See this real numbers has natural numbers, whole numbers, integers, rational and irrational numbers. What are natural numbers? The numbers that we use for general counting purpose, like 1, 2, 3 and so on. We start counting by 1 only, right? Do we start counting from negative integers? No, we'll start counting from 1 only. 1, 2, 3 and so on till infinity. Natural numbers start from 1 and they go till infinity. Then comes your whole numbers. Whole numbers are just natural numbers plus one extra element. You have 0 over here. They are just natural numbers plus 0. 0 plus entire natural number set. They start from 0 and they also go till infinity. Okay, whole numbers start from 0 and go till infinity. Then comes your integers. Integers has negative integers and positive integers and of course your 0. Right, they start from minus infinity and they go till plus infinity. They start from minus infinity and go till infinity and of course they have 0 in them. Okay, then rational numbers. Rational numbers are the numbers which can be written in the form of p by q or p upon q. Okay, any number, if you can write any number in the form of p by q, then you can say that that number is a rational number. Here we have examples as 1 by 2. Of course 1 by 2 is a rational number because it is written in the form of p by q, and also here if your q should be greater than 0. Sorry, your q should not be equal to 0. Okay, what happens if q is equal to 0? If suppose my number is p by q, I am assuming that q is 0. So what is it? You know that anything by 0 is not defined. It is not defined, right? Not defined, or you can say infinity or anything. Okay, so that's why here our q should not be equal to 0. Q can be any other number, any other integer. Okay, then 5 by 9 also in the form of p by q. 4 is an integer, no? How did it come here? Because 4 you can write it as 4 by 1. There is no harm in writing 4 as 4 by 1, right? So now here this is in the form of p by q and hence it is a rational number. So all our integers are rational numbers. All the integers can be written in the form of p by q and hence all the integers are rational numbers. Okay, then comes irrational numbers. Irrational numbers are the numbers which cannot be written in the form of p by q. They cannot be written in the form of p by q. No matter what you do, they can never be written in the form of p by q. For example, square root 2 and 4th root 5. All the roots like square root 2, root 3, root 5, anything under root is irrational number. We have seen all these things in class 9, like root 2, root 5, all these numbers are irrational numbers. Also there are two other numbers, pi and e. They are also irrational. They cannot be written in the form of p by q. Okay, you might say pi we take it as 22 by 7 for calculations. Why pi is not irrational? No, actual form of pi is not 22 by 7, it's something else. But we we take it as 22 by 7 or 3.14 just for the sake of calculation. Okay, so pi is an irrational number and e is also an irrational number, right? So yeah, next comes another two types of numbers. You have prime numbers and composite numbers. Let's see, what are prime numbers? Prime numbers are the natural numbers that are divisible by 1 and itself. The numbers that are divisible by 1 and itself are called prime numbers. Okay, so prime numbers has exactly two factors, 1 and the number itself, right? Examples we have here 2, 3, 5 and 7. Let's take 7. Then what are the factors of 7? What are the factors of 7? So you have 1 and 7, right? Are there any other factors for 7? No, you have only 1 and 7. So it is a prime number. 5, what are the factors of 5? What are the numbers that divide 5? 1 divides 5, and then comes 5. 5 divides 5. So the factors of 5 are 1 and 5. There is no other number that can divide 5. So such numbers are called prime numbers. Then comes composite numbers. The natural numbers that have more than two factors. More than two factors. Okay. Composite numbers has more than two factors. Any number which has more than two factors are called composite numbers. Okay. Let's take the number here. You have examples 4, 6, 8, 9, etc. No? I am taking 9. Okay, what are the factors of 9, or what are the numbers that divide 9? 1, of course, 1 divides 9. Then 3 divides 9. 3 3s are 9. And of course 9 also divides 9. So how many factors we have here? 3 factors. By definition, a number which has more than 2 factors is a composite number. So 9 is a composite number. Any number that has more than 2 factors is a composite number. Okay. Let's see this number 1. Number 1. What about 1? Whether it is prime or composite? Prime or composite? How do you define 1? Like, or how do you, where do you put 1 in the prime number set or composite number set? We'll check the factors of 1. How many factors does 1 have? 1 divides 1. 1 is divided by 1. And does any other number that divides 1, or does 1 have any other factors? No. 1 has only one factor, which is 1. But by the prime number definition, we know that prime numbers are the numbers which has 2 factors. It should have at least 2 factors, but our number 1 has only one factor. So it cannot sit in the prime numbers definition or prime number set. Then our composite number definition says that a number should have more than 2 factors, but our number 1 has only one factor, so it cannot sit in the composite number set also. So 1 is neither prime nor composite number, as it has only one factor. So it cannot be prime, it cannot be composite, right? And 2 is one and only even prime number. 2 is an even number, of course we know that. And 2 is also a prime number. Why? Let's see. What are the factors of 2? 1 divides 2, and then 2 divides 2. Are there any other factors? No. So 2 has exactly 2 factors, which means it is a prime number, right? 2 is the one and only even prime number. There's no other prime number. There's no other even number which is a prime number. Because we know that any even number can be written in the form of 2n, right? So by default 2 is a factor of that number, right? So obviously there can never be another even prime number. 2 is one and only even prime number. Okay. Then what are we going to learn in this chapter? Okay. First, of course, Euclid's division lemma and algorithm. These are very important. You have many problems based on HCF and LCM which use Euclid's division lemma and algorithm. We'll see this. Then fundamental theorem of arithmetic. Of course, the name suggests that it's a fundamental theorem of arithmetic, and it is important to learn arithmetic. Okay. Then proofs of root 2 and root 3 are irrational. We already know that root 2 and root 3 are irrational, but we need to prove that. Okay. Somebody told you root 2 and root 3 are irrational and we have believed. No, we need to prove that. We'll prove that in this chapter. Okay. Then discussion of examples and exercises. Of course, we'll discuss all the examples given in your textbook and we'll solve all the exercises in your textbook. Okay, that's it for now. That's it for this video, and I'll see you in next video. Until then, bye bye.